Okay, so today we'll be solving questions of trigonometry, which will involve basically some right angle triangles or some not right angle triangles, sine rule, cosine rule, and we'll understand how and when to apply what. Remember that the sine rule and the cosine rule are already provided on the front page on the formula sheet. I'll just copy that down. So we must understand when to apply what and how to apply it successfully. So these are the sine and the cosine rules that have already been given in the exam. So the first question that we'll do is, now the syllabus of IGCSE and O levels is all the same. So we'll be doing IGCSE May June 2025 paper 4-2. It's a paper in which calculators are allowed. And the first question that we'll be doing is question number 20 from this paper. Okay. So the question has given us, the diagram shows a quadrilateral ABCD. CD is 10 and BB is 12, already given in the figure as well. But don't forget to read this description sometimes if some very important data is provided in these words. And we need to calculate the length of AB. So in order to calculate the length of AB, which triangle will we focus on? We will focus on triangle ABD. It is a right angle triangle, so I do not need anything but SOHCAHTOA or Pythagoras theorem. So I will be applying, as per the angle, I need the opposite of 34. I know the adjacent, so I'll be applying tan. Tan theta is opposite upon adjacent. So tan of 34 opposite is AB, adjacent is 12. So AB is 12 tan 34, that is the value of AB. Now you can use your calculators to find this value. It is 12 tan 34. And you get your value of AB, rounding it off 8.094, 8.094, rounding it off to three significant figures, 8.09 centimeters or meters. Meters. Okay. Writing the length so that if I ever need to convert these lengths, I know which length was I dealing with. Moving on to the second part, part B, in which the question is telling us to calculate the area of the quadrilateral. We can split the area into two different triangles. One is triangle ABD and the other is triangle BCD. So how do I find the area of ABD, area of triangle ABD, which is a right angle triangle, area of triangle ABD? I'll be doing it through half into base into height. So my base is 12 and my height is the length of AB that I found in the previous part, 12 tan 34, or I can write the decimal value 8.094. So what is the area of triangle ABD that you will end up with? What you can do in the calculator, you can use this value, answer multiplied by 12, multiplied by half or 0.5, and your area of the first triangle is 48.565. 48.565. I'm not over rounding off because this is not my final answer. Then area of triangle BCD. It is not a right triangle and I do not have the height, so I'll be using area is half AB sine C. In this one, I need any two sides and the angle between those two sides. So I'll be using one side as 12, the other 10, and the angle between them is 56. So half into 10 into 56. Sorry, half 10, 12, and the angle is 56. 10, 12, and sine of 56. So area of triangle ABD is half into 12 into 10 into sine of 56. So we'll end up getting 49.742. 49.742. Now I have both the areas, area of quadrilateral A, B, C, D. I just need to add the two areas, 48.565 plus 49.742. I'll just take this answer and I'll add 48.565 and the area will be 98.31 or 98.3, correct to three significant figures, meters square. So this is how we have done part B. Moving on to part C. Part C wanted us to calculate the perimeter of quadrilateral A, B, C, D. Perimeter is total length of the boundaries. What lengths do I know and what do I not know? So I do know 10. I do know this length, which is 10. I do know the length of AB. And there are two more boundaries to this quadrilateral, which I currently don't know. One is the length of AD, and the other is the length of BC. Remember, you will not add the length of BD because that is not a boundary of the quadrilateral. Perimeter is total length of the boundaries. So I need to figure out these two lengths. First, I'll figure out the length of AD. I will focus on the triangle ABD, which is a right angle triangle. And using the values provided, I will use cos theta, which is cos theta is adjacent over height. Cos 34 adjacent is 12. I do not know the hypotenuse, which is the length of AD, so I will call that AD. AD cos 34 is 12 and AD is 12 upon cos 34. Now you can use your calculators to find this length. 12 divided by cos 34. 14.475. 14 point. You can use it as it is as well. Because it is not your final answer, I recommend you to use the value of AD as it is. Because the calculator is the one which will have to calculate the value for you. The other length that I need is BC. For that, I'll be focusing on triangle BDC, which is not a right angle triangle. And because I need this length, I have the remaining two lengths and the angle, corresponding angle. So I'll be using the cosine rule. And I'll be using it for triangle BCD, and I'll be finding the length of side D. If this is my angle D, the length in front of this angle will be called D. So I'll be using it for side D. The other two sides are B and C. So how can I write it? The formula will always be provided, cosine rule. Just tailor it as per your need and use it. So you can write it for D square. The other two sides are B and C minus 2BC cos of D. So D, the length D is basically named as BC. I'll be calling it BC squared. And the other two lengths are 12 and 10, and the angle is 56. So 12 square, 10 squared, 12 into 10 into cos of 56. You do not need to use the calculator at this moment. You square root on both sides, and now you can put this in your calculator directly, get an accurate answer. This will give you the length of BC. I will tell you how to put it in your calculators. So how can you put it in your calculator? Make sure you use appropriate brackets when needed. 12 square plus 10 square minus 2 into 12 into 10 cos of 56. Close the bracket. And your value of BC is for 10.478. 10.478. And for your perimeters, you will add all the lengths of the boundaries. I have 10, AD, AB, and BC. So the ones that I have as exact, I'll be using them as it is. AB, I can use 8.094 or 12 tan 34. Both are okay. I'll tell you to use 12 tan 34, 12 upon cos 34, and BC is 10.478. So use the calculator appropriately. 10 plus 12 tan 34, make sure you close the brackets, plus 12 upon cos 34, and then plus 10.478, 43.0 meter is your perimeter of this figure. So in total, it was a question of 5. We still have another part, which is part D. Okay, part D wants us to find the shortest distance from B to the line AD. From B to the line AD. How will I do this? If I want to find the shortest distance from B to the line AD, let's see this. Now B to the line AD can be any distance. If I move this green line is the distance from B to the line AD. What will be the shortest one? The shortest one will be the perpendicular distance. And this will make a 90-degree with the line. This is the shortest distance that I need. Now this is a right angle triangle that I need to focus on. So I'll focus on this triangle. Now 12 becomes the hypotenuse because it is an angle in front of the 90-degree, which is the longest side of this right angle triangle. I need the opposite, and I'll be using 34 degrees. So I need the opposite, which is the shortest distance, and I'll be calling it X. And I know the hypotenuse is 12, and opposite and hypotenuse, so I'll be using sine to find the shortest distance from B to the line AD. So I'll be using sine theta is opposite upon hypotenuse. Sine 34, opposite is what I need. Hypotenuse is 12. So 12 sine 34 will be my shortest distance that I'm looking for. And that is just 12 sine 34, 6.71 meters. So this question was for 3, 5, 8, and 3, 5, 8, and 5, 13 mark question. Okay, class. So the next question is June 25, paper 4, 1, question 17. The diagram shows a quadrilateral ABCD. ABCD, it's a quadrilateral. It has already been split into two triangles for us. We need to calculate the length of AD in the first part. How will we do this? If I need the length of AD, I have the other two sides. I have the angle which is in front of AD. So I'll be using cosine. How will I label the sides? If this is D, the side in front of D is D. If this is B, the side in front of B is B. And this is A. So I'll be focusing on triangle ABD. I'll use cosine rule to find the length B. So I'll just write the cosine rule once with respect to this triangle minus 2AD cos B. Cosine rule will be provided. So AD square is 12.1 square plus 9.6 square minus 2 into 12.1 into 9.6 cos 56. I don't need to use the calculator at this moment. Plus 9.6 square minus 2, 9.6 cos 56. Now I can put this entire thing in the calculator, get my answer, which is 12.1 squared plus 9.6 squared minus 2 into 12.1 into 9.6 cos of 56. So it is 10.424. 10.424 meters, and if I want to write it correct to three significant figures, 10.42, 10.4 is the answer. Moving on to the second part of this question. The question wants us to find the obtuse angle BDC. Now, if the question needs obtuse angle BDC, that means angle D is what I'm looking for. If I wanted to use the cosine rule to find an angle, I must have all the three sides. Remember, I'm focusing on triangle BCD. I do not have all three sides of this triangle, and I need an angle. So I'll be going for sine rule. If I have this, I need to find this angle D. Do I have the side in front of it? Yes, I do. This is side D. And I have another pair of angle inside, which is side C and angle C. I always recommend students to write sine rule in their own favor. Start with the unknown. So if you want to find angle D and you are using sine rule, start with D, sine D upon D. And then write another pair of angle inside. In this case, I have sine C upon C. The sine D and the length of D is 15.8 is equals to sine. The angle C is 47 and side C is 12.1. 47 upon 12.1. No need to use the calculator at this moment. 15.8 is dividing on the left side. If it goes on the right, it will multiply. 15.8 sine 47 divided by 12.1. No need to use the calculator even at this moment. Sine inverse, and you can sine inverse this entire thing to get your angle D. But here is a particular thing that you need to know. If I go for sine inverse 15.8, I'll just put the entire fraction. 15.8 sine 47. Make sure you close the brackets or else you'll get syntax error. 12.1 bracket closed. 72.7 degrees. Now the calculator, whenever we inverse the sine, it never gives us an obtuse angle. But we do know, we have studied this, that sine gives us the same value for two supplementary angles. The question already specified that it is an obtuse angle BDC. The calculator will never give us the obtuse for sine inverse. So we can find it on our own. BDC. Angle BDC will basically be equal to 180 minus 72.7, which will be equal to the supplementary angle of 72.7 and 107.3 degrees. Those who are unclear about it, kindly visit my other video and understand the sine and cosine of obtuse angles. And part C, the question wants us to calculate the area of the quadrilateral. It has already been split into two triangles. I can find the area of each triangle by using half AB sine C. But please be sure that you take two sides and the angle between those two sides. So you have these two sides, 9.6, 12.1, and the angle between them. But what about triangle BCD? You have the two sides, but you do not have the angle between them. So first, you will want to find angle B. When you will get angle B, only then can you use it for the area. So area 1, let me call for the first triangle, which is easy. I'm calling it area 1 half AB sine C. Area 1 half. Now, one of the lengths is 9.6, the other is 12.1. 9.6 into 12.1 into sine 56. This will give me the area 1, which is half into 9.6. You can use brackets or the multiplication sign into 12.1 into sine of 56, 48.15. Do not over round at this moment because you will have to add this because the length was in centimeters. पहले मैंने meters में क्यों लिखा? I'll rectify the unit of length. Was in centimeters. Yes, units are provided, but I recommend you to focus on the unit so that if you need to convert it in the end, you are well aware of it. So this is centimeter square. Now I'll have to find angle B for the other triangle. How will I do it? I'll say angle B plus 107.3 plus and what is the third angle? 47. If I would have added all three, I would have got 180. So what is my angle B? 180 minus 107.3 minus 47. And the angle that I end up with is 25.7. So area 2 again, half AB sine C. Now the two lengths that I'm considering are 15.8 and 12.1. 15.8, 12.1 and sine 25.7. So my area 2 is 1 upon 2 into 15.8 into 12.1 sine 25.7. So this is 41.45. So my final area that I will end up with is area of quadrilateral. I'll add both the values. I'm just calling it the total area, which is this plus 48.15, 89.6 centimeters square. So this will be your area of the quadrilateral. This again is 3, 4, 7 and a 10-mark question from the new syllabus, from the new pattern.